Hey everybody, Lars here. First time we're doing things, I don't want to say live because it's not really live streaming, but it's the first time I'm filming for you guys in spring of 2020. 2020, bizarre. I wanted to jump on real quick. I know it's nearing the end of Unit 2, but now, as you probably know, you've gotten to the point where you kind of know how the class runs. You kind of know how we do units, and you have enough simple things under your belt that you can start solving problems now and you can start doing things. And as you know, at the end of the Unit 2 slides, I suggest you go do what's called an Euler problem. It's called Project Euler. And the story goes, I'm working in the computer science department. And back 10 years ago, we started a new kind of collaborative computer lab. Kids weren't coming to our labs because they had laptops, they had devices themselves. Java was free. The program that they used to create, act as their editor, like you're using Idle, well, they would use a program called Eclipse, and Eclipse was free, and they had no reason to go to the labs. They could go to the student center, they could go to their dorms, they could go do their coursework wherever they wanted to. So we wanted to try and find a way to get kids to come back to the lab. So we created a collaborative space, less about the gear, more about movable furniture, powerful, wireless, different things along those lines, because students have their own devices now. So we created the cave, and it was popular, and then it's basically now the headquarters for the undergraduates in computer science. The point being is that people would walk into the room 10 years ago and say, I want to learn Python. How can I learn Python? And at the time, there are no Python classes here at Rutgers. My class doesn't exist yet. A couple others don't. And what we used to tell them was, go to a site called Learn Python the Hard Way. And you're going to learn what that is in a little bit because we're going to use it for the midterm assignment. And when you've done that, then go to Project Euler and do the first 50 problems. And if you teach yourself Python and learn Python the hard way, and you go to Project Euler and do the first 50 problems, I think at the time the first 50 problem made you like in the top 5%, or maybe it was the top 3% or something like that. And then after that, you pretty much know Python well enough that you're learning a language to do something with it, right? You probably have enough to go get started and start going down that road and working on that particular project. So I used to send the students down to Project Euler. So once you have rudimentary skills, and now you're done with Unit 2. And when at the end of this video, we'll talk about announcements and we'll talk about some logistics and different things like that. You're dealing with simple data now. You're dealing with if-then. You're dealing with loops. You're dealing with the basics of the language. You know data representation. You know how to navigate using loops through your data now. You can actually solve some problems and do some things. So it's around now in this particular class that I want to introduce Project Euler. So basically what I do, oh, forgive me, it's cold. And it's not a good thing to do. I know that. I'm not unaware. But technically you shouldn't solve or publicize solutions for Project Euler problems because they're always the same. And if I show somebody how to do it, well, then I'm taking away their chance to do it themselves, right? If you go to Stack Overflow, you'll see that maybe the first 100 Euler problems are pretty much solved for Python, Java, and C++. But the idea is go to an Euler problem and try to do it yourself, right? Plus, we tackle Euler 6, which is no great shakes. It's not the hardest thing in the world. So anyway, let's do that. Let's attack Euler 6 and see what we can do with the tools that we have for the first couple of units. Oh, I hope this doesn't make this video miserable. All right. As you can see up here, and I'm outfitting a new laptop here because I just got myself a new laptop. So hopefully things are going to work. Things won't be too clunky. Let's see. New file. Excellent. I'm going to come over here. I'm going to give myself a couple of comments. I will say there was, and I will say playing with Euler. 6. And it's pronounced Euler. It's not pronounced Euler. It looks like Euler, but I made that mistake in class once and got laughed at. Okay. So, what's the problem? Basically, I came over here, and I've created a user ID for this particular class. So if you go to Project Euler, which is projecteuler.net, and then it brings you to About, you'll see this page right here. If you go to sign in, and I'm not going to sign in as me because you're done. I'm going to sign in as PMDS Spring 20. Okay? And if you, and anybody can do this, put in the password Python class, and then you put in their little code here to prove that you're not a bot. Then you can sign in. And as you can see up here, this is just for our class. Okay? So now you have all of the problems listed, and you can pick the ones that you want to go attack and you want to go solve. So what we're going to do is come down here. We're going to look at number 6. And you can see that number 6 is the sum of the squares for the first 10 natural numbers is, and you can see it adds up all of the squares from 1 to 10. And you get 385. And then the square or the sum of the first 10 is you add all the numbers up, you get 55, and then you square that, and you get 3025. Then you take the difference, 3025 minus 385, and you get 2640. Okay? So that's the sum square difference for the first 10 numbers. But Project Euler is saying it wants to find the difference between the sum of the squares for the first 100 natural numbers. So we can add up all the squares, and we can add up all the numbers, and then square that and do that, blah, blah, blah. But we want to use programming, okay? And when we use programming to try and find that answer, we're going to come here, we're going to put the answer in here, and we're going to check to see if we get the right thing. What I usually do with Project Euler problems is I will highlight the problem, copy and paste it, and then I jump out here, 1, 2, 3, and I just paste the problem in there, okay? Boom. So now we have it there on the screen. Now you got to realize that's 1 squared, that's 2 squared, so it doesn't come over perfect. But, and I need 3. There, that's going to work. So now, write in my program, and I'm going to save it right now. I'll just call it E6. So now, and you can see it popped it right up there on my desktop. I don't know if you saw that. I don't know how zoomed in I am. Because I know if you zoom completely out on one of these screens, you can't read the Python. So I'm guessing I'm probably zooming in for you. All right. Let's solve that problem that we're looking at right now. That's kind of what in education we call a worked example. Let's solve that. And then if we can solve that, then I think we can alter our numbers and get the real thing solved. So I want to find the sum of the squares of the first 10 natural numbers. All right, I'm a Python programmer. I am going to do this. I'm going to create a variable called SOSQ, called sum of square. And I'm going to set it equal to 0. You'll see why in a minute. And then I'm going to say for I in range 111. 11 is the first thing I don't want. Remember, it's exclusive. And what am I going to do? I'm going to say sum of square is equal to sum of square. And I'm going to add I. Boom. So every time I go through this loop, I'm going to square the number, and I'm going to add it. Okay? You remember the second video? The video on loops when we did the accumulator? This is basically what we're doing. We're just doing a little accumulator. So then print, and now I'm going to come out of the loop, and I'm going to test it. All right. I'm hitting Control-S to save, so there's no magic here. I'm not coming up here and saving like that. I'm hitting my Control-S, and then I'm going to hit my F6 to run, or my F5 to run. Okay? And then when I run things, I get 385 up here. And as we saw up here, 385 is the answer. So we know we're good with the first part. So what's the second part? Square the sum. So I'm just going to say square the sum equals 0. Okay? Now, you might be saying, why are you setting that thing equal to 0? Well, the reason I'm setting it equal to 0 is because I use it right here Okay, well, actually, that's not true. It's because I use it right here. Python evaluates expressions from right to left, yeah? So in my expression, I use a variable right off the bat. And if it doesn't exist yet, Python is going to say, what is going on here? You know what? I'm going to show you. If I come in here and I comment out that variable declaration and I run this code, it blows up. It says SOSQ is not defined. Why are you trying to use it? What are you doing to me? All right, so what you need to do is create it. And then if you create it, then it just sees a variable that's 0. And then everything is hunky-dory. So now if you rerun, you're good to go. Okay, so now I got SQOS. So what am I going to do? Same thing. I'm going to say for I in range 1, 0, 0. What did I say? 0, 0, 1, 11, because I want to go from 1 to 10. And now I'm going to do square of sum, but I got to do a little trick. I'm going to say square of sum plus I, and that's it. Because what I want to do is add them all up, right? And then get the total. If I do 1 through 10, it's only going to be 55. But then when I get that 55, that's when I want to square it. So I'm going to square it out here outside the loop. Okay? I want to use my iteration to add up all the numbers, and then when I come back out of the loop, then I'm going to square it, right? Because I want the square of the sum, not the sum of the squares. And then in order to know that I'm okay, I am going to print that out, and we are going to run, and you can see that says 3025, and if we look up here, 3025 is what we want. So we're in pretty good shape. We really only have one last thing to do, and I'm going to do it right in the print line. I'm going to say the diff is, and then I'm going to say SQOS minus SOSQ, and that should give me the difference. And the difference is 2640, and if you look up here, the difference is 2640. All right, we're in really good shape now because we have a little piece of code right here that solves the problem we have up here, but we're not done yet. It says find the difference between the sum of squares of the first 100 natural numbers and the square of the sum. So what would we do if we wanted to find that solution? Because we use programming, it's pretty easy. All right? Notice that pregnant pause where the viewer can figure out the problem themselves. All we're going to do is look, boom, 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 done. We're going to take the range of numbers and we're going to go, instead of going from 1 to 10, we're going to go to 1 to 100. And we're going to add it all up. I'm going to rerun, and I'm going to get that big old number right there, 25164,150. Okay? What is that? 25,164,150. All right? So that is what our program comes up with as the answer for that. Okay? So we might as well do it now. Let's highlight that. And go back to Project Euler where we have the, well, here, no, let me do that. Where we have the problem that we logged in as our thing. So we can put in the answer, paste, and then we can hit check to check if we have the right answer. I'll tell you right now, we do. All right? So this is one of the biggest buzzes in programming. When you hit check, why is it taking so long? Doon, 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 doon. Yeah, look at that. You get the big green check mark if you've gotten the problem correct. And we are the 470,000 something person to have solved the problem. Okay? Difficult rating of 5%. Not exactly the highest difficulty rating. All right? But right off the bat, we have now solved an Euler problem. So if you go to progress, you can look here and look, we got that number 6 problem licked. I think we got a little work to do. But look, and we can always come back, click on it, and because we've solved it, it'll tell us what the answer is. Okay, and it'll even tell us when we solved it. And what's neat about Euler is that you can come and you can get statistics on all the problems, who solved what problem, and boom, boom, boom. I think if you solve 50, you're in the top 5%. I bet you it was 5%. It's a little higher than 5%, but if you do 50 Euler problems, you're at about 5%. So that's pretty good. A lot of these problems, as they get older and older, they get hard. There are some hard ones. There are some that not a lot of people have solved. You have some here that are unsolved. So Euler problems are pretty good. All right. So we solved the first one, and we now know that our answer is correct. But we're not done yet, because my programmer brain sees this particular situation and doesn't like it, because I had to go into this code and change it in 2 different places. What if I had a variable called limit, and I just made limit equal to 10, and I came in here, and for the end of my range I just said limit. Now I've only got to make the change in one place, right? But would that work? There's that pregnant pause again. Would that work, what we just did? It wouldn't, because limit is 10. And I want exclusive at the end of a range. I want the first thing I don't want. So what a lot of Python programmers do, and this is the reason I'm showing it to you, is if you want to have a limit where you're actually putting in the limit you want to use, like 10 or 100, you can't expect the user to play your little Python games. All you do is this. You tack the 1 on the end of it. So you do limit plus 1. That'll take that 10 and make it an 11, and that'll make your loop work properly. And then if we make it 100, it'll work. So now if I run it with the 10, I should get the 2640, and I do. And then all I have to do is make the change in one spot, and boom, I get the new result for 100. So now my programmer brain is a little bit happier. It's not really happy. It'll be happy in 2 weeks when I do the video with functions. Then it'll be happy. So that's kind of getting efficient. Even if we wanted to, we could say limit is equal to int input. And we can actually have the user just input it, give me the limit 100, boom, and then it does it for 100. And then it can say, give me the limit 10, and I do it for 10. So I can even have the user input it, okay? So that works that way. That is how we do Euler 6 with what we have now, okay? Unit 2 is going to end tomorrow, and then we're going to get to Unit 3, and Unit 3 is going to be functions and file I/O and libraries and modularity and stuff like that. But what you're going to learn is that after you're done with Unit 3, you basically know 80% of the Python you're going to know, okay? And then after that, we start solving problems, and we start doing different things with Python. Once you get Unit 3 under your belt, we're going to come back and we're going to redo Euler 6. And when we redo Euler 6, we're going to do it in a way that we use functions and we use some other stuff, and it's boom, boom, boom. It's going to be a lot more simpler, and it's going to make a lot more sense to you when you see it done that way. Then, at the end, is a little parlor trick. I'm going to teach you something about a thing called list comprehensions, and we're going to take this problem, and we're going to solve it in one line. All right? Now, I don't expect you to do all of that stuff after we do it. It's a little bit of a trick, but you'll see that once you get fluency with the Python language and you know how to do things, then you'll be able to do a lot of these problems just in the interactive window, okay, with a simple line of code and simple thing like that. All right, so that's the solution for Euler 6. I am not going to put it up on Canvas for you to download. It's here in the video. You can stop the video and look at the code and code it up yourself and play around with it, because that's how we learn, if you haven't figured that out yet. All right, all right. I, for the first time, am going to do some live and in-person announcements. I want the announcements to be useful for you. I don't want the announcements to come off as me just screaming and yelling like some old man. Get off my lawn. But I am going to start off by saying, do not send me email asking for a makeup if you miss a quiz. If you miss a quiz, you miss the quiz. There's no makeups. Near the end of the course, at the end of Unit 4, there's going to be an extra credit program. If you do that extra credit program, you'll be able to recoup 5 points. So if you miss a quiz, which is 7 points, you can get 5 of them back if you do the extra credit. You need to keep up to date with when units end and when the quizzes end. I thought about not ending them at 2 a.m. because people get confused, but at the end of the day, it's usually only 1 or 2 people that get confused, and the other 70 are fine. So why am I going to take away those 2 hours from 70, people? Because 1 or 2 people got confused. It doesn't seem fair to me. Quizzes are the only synchronous activity we really have. 30 hours at the end of units. You've done the first quiz. They don't get a whole lot harder. They're about a half hour's work, and you have 30 hours to do it. So I think that's reasonable. If you miss a quiz, it's because you're just not playing. It's because your head's not in the game. All right? And I'm not going to make my TAs go through the process of doing makeups and doing all of that because your head's not in the game. So make sure you're attentive. Make sure you know what's going on. Grad school is about planning. Grad school is about, having your head in the right place and knowing what you're doing. All right? Another thing, don't send me, and this sounds ogreish, and I don't mean it to sound ogreish, but 3 or 4 days before assignments are due, don't send me assignments and say, how is this? Okay? You have to submit for a grade and get feedback when you submit for a grade. Because if me and my TAs looked at everybody's code before you handed it in, then we would have to look at 70 programs every day for about a week until they were perfect and you handed them in. That's not the way it works. You have to do assignments. You have to hand it in for a grade. Okay? Second thing, don't send me .py files because my Outlook, for whatever reason, the Outlook that goes with Rutgers doesn't let them through. It sees it as a security nightmare because technically it's code that you can execute, so it doesn't like it. So if you send me a .py file, I'm not getting it. All right? If you want me to look at some code because maybe you're doing an exercise or you have a problem or you have something going on, then I'm more than happy to help out and look at it. Send me email, but you have to put the code in the email so that I can cut and paste it. Do not send me a screenshot, okay? I'm not going to do OCR and be able to cut and paste from a screenshot. You send it in the body of the message, and then that gets through. As long as it's not a .py file, then that gets through, okay? So you can do that. That's fine. Other than that, I think because of what I'm seeing, most people are good. Most people understand, okay, a unit is a certain amount of time. You got to do your discussion post 3 days before the end of the unit. You have 30 hours to do the quiz at the end of the unit. Assignments, you get 2 extra days. If you're not done with the assignment on the day it's due, hand it in the next day. It'll cost you a point, but it's only 1 point, okay? Most assignments are worth 6. You'll see down the road some of them are worth 8 and the other one's worth 4. But if you're a day late on an assignment, it only costs you a point. So that's not so bad. Again, I always say in the announcements, if you're doing triage and you're up against time because you didn't plan well and you got to do things on the last night of the unit, do the quiz. Don't mess with the quiz because you're not getting another shot at those 7 points. The assignments, you can hand them in late. If for whatever reason something happened and you can't get things in, then do the assignment late. Don't do the quiz late because the quiz, there's no makeups. All right? I hate rules and all this ogreish yelling and blah, blah, blah. But people say, hey, can I do a makeup? Can I do this? Can I hand? No. We have the rules so we don't run into situations where my TAs are running around having to remember 10 different things. All right? Anyway, it's not that bad. Other than that, everybody is doing great. I like the fact everyone is going to – usually when I used to teach this class, I used to do it as a hybrid. So you would meet once a month. So it's not like we're taking a brick and mortar meet twice a week class and doing it online. It's really something that was made to be mostly online. But still, when that once a month when we met, I was able to do housekeeping questions and answer people's questions about different things. So I don't want you – I do a lot of announcements and I do – a lot of stuff in the units because I want you guys to stay active. I want you guys to, not think it's like some online class where you can just go away for a week and then come back and then, because that's a crummy way to learn. I want you to do something like every couple of days so that it stays fresh in your mind. So I try to make it so that if you spend a half hour a day every other day, that's fine. You can complete the unit that way. I don't want you to spend 3 hours on weekends once every 2 weeks. Because that's a crappy way to learn all of this stuff, and that's when you run into trouble. All right? That should be good for now. Quiz is going to open up tonight at 8 o'clock. It'll run for 30 hours. Assignments are due tomorrow for Unit 2. I'm going to get you the information on the midterm project like in the next couple of days, I'm guessing. And so you'll have time to do that. I don't think I've done that already. I will do that and make sure that you're good to go on that. So no worries. Everybody's going good. Next unit will be Unit 3, which is a 3-week unit. But I'll also hop on and do a new video fresh for spring 2020 like this when I resolve Euler, because we'll do another thing with Euler where we solve Euler with functions and make it a little even shorter than that, and then I'll show you the trick with list comprehensions, and we'll be able to do Euler in one line. All right? All right. Good to go. You be good. You guys keep doing what you're doing because everybody's doing great, and I will see you later. Take care. Bye.